Electric potential difference, solving for delta E and Q by Kulsoom. Electric potential difference, also referred to as voltage, is the change in electric potential energy associated with charges at two different points in a circuit. Here is the equation, where V equals the electric potential difference measured in volts or joules per coulombs, delta E equals the change in electric potential energy measured in joules, and Q equals the amount of charge measured in coulombs. In this video, I'm going to solve for both delta E energy and Q charge. To start off, we have to rearrange this equation to solve for energy. To do so, Q, or charge, must be moved to the other side of the equation through multiplication. This will cancel out Q, leaving delta E alone on one side of the equation. So, delta E, or energy, equals charge multiplied by voltage. Now we can start on our first problem. Calculate the energy transformed in a 15-volt adapter that has 0.075 coulombs of electrons moving through it. First, we write what is given to us. In this problem, we can see that the voltage is given at 15 volts or joules per coulombs, as well as the charge at 0.075 coulombs. Next, we write what is required, which in this problem is delta E, measured in joules. Next, we write our original equation, which is V equals delta E over Q, along with our rearranged equation, which will help us solve for our unknown variable, delta E. Next, we see if there are any conversions which have to be made to the information given to us. In this simple problem, there aren't any conversions needed, so we are going to move on. Now we fill all of the given information into the equation and solve for delta E. Next, we write our full calculated answer in joules. Now we can look for the lowest amount of significant digits in our original numbers, which in this problem is 2 significant digits. So our final answer will also have 2 significant digits. Finally, we phrase our final answer into a sentence. So, therefore, the amount of energy that was transformed is 1.1 joules. Now that you have learned how to solve for delta E, we can move on to solving for Q. So just like our first problem, we first have to rearrange the original equation to solve for our unknown variable, Q. To solve for Q, or charge, we must multiply Q on one side to move it onto the other side of the equation. Next, we divide the voltage on one side to move it onto the other side of the equation to leave charge on its own. So, the final rearranged equation should be Q equals energy divided by voltage. Now we can start on our second problem. The potential difference across terminals of a light bulb is 120 volts. If the bulb transforms 480 joules of energy, how much total charge is moved across the terminals? So, just like in the first problem, we start off with writing down what is given to us. In this problem, we can see that voltage is given to us at 120 volts, or joules per coulombs, as well as energy at 480 joules. Next, we write what is required, which in this problem is charge, or Q, measured in coulombs. Now we write down the original equation, which again is V equals delta E over Q, as well as our rearranged equation, which will help us solve for our unknown variable, Q. Next, we see if there are any units which need to be converted. In this simple problem, there are no conversions that are needed, so we will move on to the next step. Now we can fill all the given information into the rearranged equation to solve for Q. So Q should equal 480 joules over 120 volts. Next, we write our full calculated answer, which is 4 coulombs. And now we check to see for the lowest amount of significant digits, which is 2. So our final answer will also have 2 significant digits. Finally, like the last problem, we've put our final answer into a sentence. So therefore, the amount of total charge is 4.0 coulombs. And that's it. That's how you solve for both delta E and Q. Make sure you always remember to put your final answers into the correct number of significant digits, and never forget to put the units. Thanks for watching.